Hi, we've talked about compound inequalities, and we've talked about absolute value equations, and now we're going to sort of put those together and talk about absolute value inequalities. So inequalities that involve the absolute value of something. So here's an example of an absolute value inequality. It says that the absolute value of x is less than 3. And that's equivalent to saying that x itself is between -3 and 3. Because if you think about what x could be, if x is a positive number, then the absolute value of x is just x, and it has to be less than 3. If x is a negative number, then what we don't want is for x to be down here, like -5, because then the absolute value would be +5, and that's not less than 3. Instead, we want x to be a number over here, like -2 or -1, so that the absolute value is less than 3. So what I've got shown here on the number line, these are all the numbers whose absolute values are less than 3. That's all the numbers between -3 and 3. So the rule is, whenever you see the absolute value of some expression less than some particular positive number, you can translate that into the expression is between the negative and the positive of that number. So notice part of this looks exactly like what we started with without the absolute value bars, but then in front of it, we're writing the negative number and a less than sign. And then if it were the absolute value of some expression less than or equal to some number, same rule, but we have less than or equal to's here. Notice these are both pointing the same direction. You've got a negative number, a less than or equal to sign, the expression that was inside the absolute value bars, another less than or equal to sign, and then a positive number. So the expression is in the middle on the big side of the negative number and on the small side of the positive number. So let's see some examples. The absolute value of x is less than 8. This is just like that last example, but there's an 8 instead of a 3. So what is it going to look like? -8 is less than x is less than 8. And on the number line, here's the graph, everything between -8 and +8, and in interval notation. That would be the interval from -8 to 8. Now, a harder example. The absolute value of 2x minus 3 is less than or equal to 7. So remember the rule. When you have the absolute value of some expression less than or equal to some number, the expression has to be between negative and positive that number. So it's still less than or equal to 7, but it's also greater than or equal to -7. Now we still have to finish solving this to get x by itself in the middle. So remember, there's 3 sides, and whatever we do, we have to do the same thing to all 3 sides. So first I'm going to add +3 to all 3 sides. -7 plus 3 gives me -4. 2x minus 3 plus 3 gives me 2x. And 7 plus 3 gives me 10. Now, how do I go from 2x to just x? I divide all 3 sides by 2. So -4 divided by 2 gives me -2. The 2x divided by 2 gives me x, like I wanted. And the 10 divided by 2 gives me 5. So now I'm done solving. This says that x is between -2 and 5. Here it is on the number line here. X could equal -2, could equal 5, or could be anything in between. We showed that we are including those endpoints by putting square brackets on the graph and also on the interval notation. This is the interval from -2 to 5 including the -2 and including the 5. And now, kind of a bonus example, what happens if we have a negative number over here? Well, no solution, because remember, absolute value of anything can never be negative. And the only numbers that are less than -14 are negative numbers. So there's no way this could be true. Now let's look at the other kind of inequality where you have the absolute value of something greater than some number. If we want the absolute value of x to be greater than 3, that means x is either greater than +3 or less than -3. So x could be a positive number like 4 or 10, and then the absolute value of x would just be that same positive number and it would be greater than 3. Or x could be a negative number that's down here below -3. Could be -4 or -10. And then the absolute value would be +4 or +10 or something like that that is greater than 3. So for the absolute value of x to be greater than 3, this breaks up into two separate pieces with the word or between them. X is greater than 3 or x is less than -3. We got the numbers over here that are greater than +3 together with the numbers down here where x is less than -3. So down here on the bottom graph, the part in purple would be the numbers whose absolute values are less than 3. And then all the other numbers that I have marked in green, their absolute values are all greater than 3, except if you're right here at 3 or -3, then your absolute value is equal to 3, and those are the only possibilities. So the rule here is for the absolute value of some expression to be greater than some number, that breaks up into two separate pieces. The first piece looks exactly like this without the absolute value bars. The expression is greater than the number. The other piece has the expression less than the negative of that number. Notice these are pointing different directions. The expression is greater than the positive number, or it's less than the negative number. And if we originally had a greater than or equal to, same rule, but with or equal to's in the two inequalities that it breaks up into. So let's try a couple examples. The absolute value of 3x minus 2, or 3 minus x, is greater than 2. So here we have an absolute value of some expression being greater than some number. So this is one of those things that breaks up into two separate pieces with the word or between them. The first piece looks just like this without the absolute value bars. 3 minus x is greater than 2. Or the second piece looks like this, but with the sign flipped around, less than, and this is negative. 3 minus x is less than -2. Now we have to finish solving these for x. So I can subtract 3 on both sides and get -x is greater than -1. And then to go from -x to x, divide both sides by -1. But since we're dividing by a negative number, the inequality sign gets flipped around. So, typo here. This should say x is less than 1. There, I just went in and fixed that. So x is less than 1. Or here, subtract 3 on both sides, we get -x is less than -5. Divide both sides by -1 and flip the direction of the inequality. X is greater than 5. On the number line, x could be less than 1, or x could be greater than 5. So the interval notation has to be in two separate pieces. We have the interval from -infinity to 1, together with union the interval from 5 to infinity. Next example, absolute value of 5x is greater than or equal to 10. The rule says to write this as the expression 5x greater than or equal to the positive number 10, or the expression 5x is less than or equal to negative 10. So 5x is greater than or equal to 10, or 5x is less than or equal to negative 10. Now to solve, I would divide both sides by 5, and I get x is greater than or equal to 2, or x is less than or equal to negative 2. And what does that look like on the number line? Well, the numbers that are greater than or equal to 2 would be everything to the right of 2 on the number line, and we are including 2, so that's a square bracket. Or x is less than or equal to negative 2, so that would be all of these numbers, including the negative 2. In interval notation, it's in two separate pieces. This piece is everything from negative infinity to negative 2, and this piece is everything starting at positive 2 and going over to infinity. So it's the interval from negative infinity to negative 2, union the interval from 2 to infinity. And one more last example. If we have the absolute value of 3x plus 7 greater than or equal to negative 9. At first you might think, no solution, because absolute value can't be negative. But actually, since we're trying to be greater than or equal to negative 9, the numbers that are greater than or equal to negative 9 include all the positive numbers. So no matter what's going on, once you take the absolute value of 3x plus 7, it's always going to be a positive number, 0 or bigger. So it's always going to be greater than or equal to negative 9. And that means that you can put in anything you want for x, and this is always going to be true. So all real numbers are solutions, everything between negative infinity and infinity. So here's a summary of the rules. We started out last time talking about absolute value equations, and then here are the rules for absolute value inequalities. We always start by turning the absolute value equation or inequality into something without absolute value bars, and then we finish solving that.